Hi, welcome to the Summary of Angles video. We're just going to briefly go through all the different types of angles that we've studied in geometry this far with respect to circles. Remember, the big thing when you're looking at circles is location comes first. It's always where that vertex is located, and after you know the location of the vertex, then you choose the correct relationship that follows from that relationship. So we're going to fill out this summary of angles that you picked out in class today. So just going kind of briefly slow through this. If I look at AOB, this is a central angle because the vertex is on the center. And the relationship you need to know here is that the angle and the arc are the same size. Angle and arc are same measure. So for instance, if I would like to know what the measure of this angle is, and perhaps all I know is that AB as an arc is 50 degrees, I would know that the central angle is the same as that, it's 50 degrees. Inscribed angles are a little different because what you'll notice is that their vertex is on the circle, it's on the circumference of the circle. So vertex is on circle. And what we know about that for the relationship is that the angle is half the measure of the arc. Or you can think of it this way: if I took the angle and I multiplied it by 2, that would equal the arc. So for instance, here an example of this would look like if I know that this angle is 30, I could double its value to get the arc to be 60. So you can see that 60, this arc is 2 times bigger than that given angle. Okay, we started looking at sneaky segments and segments that have special cases. So whenever I have a tangent and a chord forming an angle, it's the same rules as inscribed angles. So you do have to be pretty sure that this is a tangent and it is a chord forming the angle. So if I look at angle ABC here, if I knew that the arc was 100 degrees, I know that angle ABC would be forced to be 50 because it uses the same rules as in any inscribed angle that we just looked at here would have. So it's going to be half of the arc it cuts, and that's true for any tangent and chord. There's a special case of a tangent and chord when we pass through a special chord. So if I have a tangent and a radius intersecting, right at this point of tangency, at point B in this case, in my bottom left corner, I know that this radius, which is just a piece of a full diameter, so you could think of it as a diameter as well, if you'd like to think of it that way. A diameter or radius and a tangent are perpendicular at point of tangency. So what that means is right here where the diameter or the radius and the tangent intersect each other, I have a right angle. And that kind of makes sense because the measure of this arc here is 180 degrees. So if this is just a special case of the special inscribed angle, this would have to be 90. And if this is 90, it's 90 on the other side as well. One other special case that we look at today, or right before break I should say, is when we have a secant and a chord forming an angle. So if I have a secant and a chord forming an angle, this is your sneaky angle. It's not an inscribed angle even though it looks like one. So it's a sneaky angle. You could think of it as secant if it helps you remember that it's involved with a secant and a chord. And basically what you would have to do is you would have to find the adjacent angle to the sneaky angle and then subtract from 180. So I would need some extra information if I'm doing a sneaky angle problem. So for instance, if they told us that the only thing we know about this circle is that arc AB is 100, then I would have to use what I know about inscribed angles to find this angle to be 50. And now if I want to find the sneaky angle, I subtract 150 from 180 to get this angle to be 130 degrees. So it's a little bit more of a puzzle piece, a little extra legwork, but that's how you would tackle a sneaky angle problem. Let's flip over to the back and take a look at these. I have 3 cases, 1, 2, 3, where my angles are all outside. So I'm just going to fill out this first rule box, but it would apply to 1, 2, and 3. So my angle is outside of the circle. And whenever I want to find an angle outside, I know that that outside angle, or angle P, is equal to the far arc minus the near arc all over 2, or farc minus narc over 2. So the same rule applies here for a tangent and a secant, and the same rule will apply when I have 2 tangents forming an angle outside of a circle. Although we did talk in class today about a special case where this angle P plus the near arc add to 180. So that's a 180 relationship, and it's only true in tangent-tangent situations. So if 2 tangents aren't forming an angle outside, this rule won't apply. So it's only going to work for a tangent-tangent. So this is a very special case just for this diagram 3, but for 1, 2, and 3, we can use farc minus narc over 2. So make sure you do fill that in for any outside angle, except the special case where I have 2 tangents that meet at a point. This angle plus the near arc, they would add to 180. Okay, one more relationship, it's our bow tie angle. So bow tie angle is a bow tie angle because it's a vertical angle. There's an angle that it's congruent to. So this angle that we're concerned with opens up to 1 arc, but we also have to consider the angle it's vertical to because it's a congruent angle, and its arc that it cuts, because both are kind of important now at this point. So if I ever want to find a bow tie angle, I'm going to use arc 1 plus arc 2 divided by 2. It's our average of the arcs. So whatever arc our original angle's across from, plus whatever angle arc our vertical angle's across from, divide by 2. It's the average here. And I know this is a bow tie angle because the vertex is in the circle, not on the center. Okay, so hopefully filling out this sheet helped you out a little bit, getting ready for your quiz tomorrow. Please review all the angle properties. Go back, look at your homeworks to get some helpful hints and types of problems that you can expect to see tomorrow. And of course, read carefully, take your time. Don't forget to draw your diagrams. Good luck studying. See you in class.